All right, so now we're going to combine the last two kind of topics that we did. We talked about the idea of forces, and then before that, we talked about collision detection. So we're going to combine those two together to create platforming. Now, you've played tons of platforming games in your time, I'm sure of it, whether it's Super Mario Brothers or Super Meat Boy or whatever your favorite platforming game is. You've most definitely played one of them of some kind. Now, how do we do this in games? Because there's a lot of complexity to this. What I mean by that is it's easy enough to make our character run across the screen and jump. We always know we can detect when it hits the ground by checking to see whether it lands at the bottom of the screen. But the problem is when we have platforms, they need to be able to interact with those platforms. So, for example, bounce off the side of them or just kind of stop movement when it hits the side of them. Or what happens when their head hits it? Do they bounce off or do they go right through the platform? And then the more complicated but still more common one is how do you land on a platform? So we know how to detect where the ground is. It's just where the screen height is. That's easy enough to determine. But platforms move. Sometimes they're in random locations. Sometimes they actually are moving simultaneously as the game plays out. So how do we actually do that? And then, of course, there's the aspect of falling off a platform. Now, normally when we're running around, we jump and the character jumps from the ground. And we can always jump as long as we're on the ground. But what if you're standing on a platform? Well, jumping, you're no longer on the ground now. Now you're standing on some arbitrary location, some rectangle somewhere in the screen. Similarly speaking, if you just walk off that ledge, what's going to happen? Now, we talked about this in the last videos with the idea of gravity and gravity always being on. And that's how we're going to deal with this. So how do we actually deal with the fact of interacting with those platforms? This is the main focus of this lesson. Normally, we just have our bounding box, our rectangle that's around our character, and we want to determine whether it collides with a platform, for example. And that's great. That's easy enough to do. We can just use the intersection methods. But that doesn't give us any clue on how to interact with that platform. So I don't know whether I'm landing on top of it. I don't know whether I'm colliding with the side of it, whether I'm hitting it from the bottom. How do we do that? Well, the way we do this is something called two-stage collision detection. Okay? And the first stage is what we already know. Collide the bounding box with the platform. If it collides with the platform, then we go on to stage 2. Now, stage 2 is a little bit more interesting. In stage 2, what we're going to do is we are going to break up our character's box. So let's go through this. So look at this. We have our Super Mario there. You can see him kind of behind the colored boxes there. And what I've done is I've broken up his bounding box into 4 shapes, 4 more rectangles. One for various parts of his body, one for each various part of his body. So one for his head, one for his feet, and then one for his left and right torso, respectively. So what we're going to do is the stage 2 is that we are going to take that bounding box, and if we find a collision with the bounding box, we go to stage 2, and stage 2 is break up that bounding box into these 4 pieces and then test collision with each one of these pieces. This basically tells us where the character interacted with the platform. Was it his body? Was it his head? Was it his feet? This can also be used in other games as well, like fighting games and shooting games, so you can determine how to interact with the player, whether it's a headshot, body shot, shooting me in the toe or something like that. You can create different results. So this two-stage collision detection is used for much more than just platforms. All right. So how do we get these rectangles? Where do they come from? Well, they're not arbitrarily made up. You have to look at your image and decide what makes sense. You'll notice that the head and the feet one are not the full width of Mario. Why? Well, because quite honestly, I want to add a little bit of realism to it. So like, for example, if you're walking off a ledge, you don't want to be standing on the ledge when your like tippy toe is standing on there. Here you can see that I've brought the box in so it's more like their heel, so that it gives it a little bit, at least a little bit more realism. And like when you're jumping on angles, you want to make sure that, like, the toe isn't what's catching the platform or something like that, or his nose, for example. So this gives us the ability to kind of break it up how we would like to make it make sense within our game. Now, how do we do that? Well, you could just choose the values. You know the position of your bounding box is the top left corner of the image. That's fine. Now, what you're going to do is you're going to use that position and the width and the height of the bounding box to kind of cut it up. Now, you could choose arbitrary values. You could say, well, I want it to start 10 pixels in from the bounding box. Maybe this is 10 pixels. I want it to be 50 pixels wide and 35 pixels high. That's perfectly fine. I don't like to do it like that. I like to do it more like percentages. So it's relative to the size of the original player. And the reason why I like to do that is because if I choose to change the size of my character, even like the original Super Mario Brothers, Mario can grow and shrink. If I'm using percentages, I don't have to change any code. It will just automatically calculate it based on the percentage I want. So for example, if I want this red box to be 60% of the width, then that means I'm going to start it 20% over from the left, and it's going to go for 60% of the width. Right? So 20% plus 20% is 40%. So the rest left over is going to be 60%. So using that, no matter what Mario is, that rectangle is always going to be 60% of that width. And that's how we're going to break up those shapes. Now, what ones are you going to use? That's completely up to you to do. So I'm trying to get through where we are here. Here we are. So the rectangle setup. This is what really matters. So for my example, I set the head to be 60% of the image width and 25% of the height. So when I calculated its location, I said, give me the image's X location and add on 20% of the image's width, and that will shift it over 20%. And then its Y value is the same Y value as the image itself. But I still have to set up its width and height, so its width is going to be 60% of the image width, and its height, it's going to be 25% of the whole image height. So that's arbitrarily how I'm doing it. I chose those numbers. I just got to make sure the math works out. Now, we don't actually see these rectangles in the game. You can see these right now because I'm choosing to show you. But in reality, they're just data, and you're just colliding with an arbitrary rectangle variable. Now, we can make them show up, and I'll show you how to do that in the demo, but you don't have to. So just to go through this, with the feet, I made that the 70% of the width. So it's going to start it's going to start 15% in, and or was he? Sorry, here we go. So where did I do this? Sorry, yeah, 15%. The left side is the X value. What am I missing here? What did I mess up? This applies. The left and the right rectangles have both a width and height of. Oh, sorry, that was those are the torso pieces. So the feet are. It's going to be 15% in, and it's 25% of the height. But the question is, where am I going to put that? That's why I kind of left that for a second and went into the torsos, because if I do the torsos first, then I can just set it at the bottom of the torso, and I know it will perfectly line up. So I'm making the torsos 50% of the width and 50% of the height as well. I think that's what I did. Yes, 50% of the height as well. And then that way it's actually going to take up the majority of that little piece there. And then finally, I can actually finish off the feet position by the X plus 15% of the width of the screen. All right, 15 plus 15 is going to give us our 30. And then the Y value. The Y value, I took it as 75% of the whole image height, because the head is 25% and the torsos are 50%. So 75% is going to put me right there. Now, if this math kind of boggles your mind a little bit, draw it out in a picture and label your diagram so you can actually see these things. It might be a little bit more clear. So let me kind of help you out with these. So there at the top, you can see that this is 25% of the height. This is 25% of the height, which means this must be 50% of the height. So I like to draw these out and label them. So what is the actual process to do this? So just to clarify, it's exactly what I said before. We're going to do what we did before in terms of we're going to collide with the entire bounding box. But what are we colliding it with? We're colliding it with every single platform. All right? So for each collidable platform in the game, we're going to check to see whether the current platform collides with the player's bounding box. If it does, we're now going to test it against the 4 body parts. If it collides with the feet, we are going to shift it so we're standing on top of the platform, and we are going to stop falling down. We're going to set our vertical velocity to 0. If we collided with the left torso, then we're going to do a similar thing. We are going to shift it so the player is just to the right side of that platform. Because remember, we collided with the left torso. So we want it to be just to the right of the platform. And again, now we're going to set the horizontal velocity to 0, and that will stop it moving over. If you want it to bounce off, then you just multiply the horizontal velocity by -1, and then it'll kind of bounce backwards. The right side is the exact same thing, only you're going to align it with the left side of the platform. And then finally, the head. So the head is, again, the same idea. We test to see whether the head collides with the platform. If it does, we're going to shift the player down so the head is lined up perfectly with the bottom of the platform. We're going to set the vertical velocity to 0 and let gravity take over. Or we could make the player bounce off of it as well, again, by multiplying the velocity by -1. And that's it. Now, this is like pseudocode. It's English. It's not actual code. So let's go take a look at the actual code. That might be a little bit more clear for you. Find it. There we go. So let's run it first of all so you can see. So I've basically taken the demo that we did from our forces, and I have Mario. I've increased things like friction and acceleration so it feels a little bit more tight as opposed to very, I don't know, whiffy. I still don't really, still not a big fan. I think he still kind of floats in the air too much. I think gravity needs to be increased. But anyways, you can see that now that the character is interacting with the platforms. He hits that edge, his vertical velocity still keeps going up, but his horizontal velocity stops. And he's even colliding with these guys up here too. And you can land on the POW block if you're keen. Tough to do. Yeah, success. Now I can edge myself off this piece, and it wasn't even fully over the toe there, right? So, because remember, our foot bounding box doesn't go all the way. All right, so let's go look at the code to see how we actually did it. You'll notice that most of the code is pretty much identical to our forces demos. So first up, I have created a couple new constants. I have a constant for each of the body parts, so I'm not using magic numbers as my index values when I'm doing those things, and it's very clear to me what represents what. It'd be a lot easier for me to understand all those different parts. All right, so we still have acceleration, friction, tolerance. You notice I've bumped these up a little bit. Acceleration is quite a bit higher. It used to be 0.2, now it's 1.1. Friction, I've bumped that from 0.5 up to 0.8 of acceleration. Tolerance, I left exactly the same because it's always based on the friction. That's much easier. Still tracking the dimensions of the screen. I'm also keeping track of the previous keyboard this time. And that's so I can turn on and turn off my collision rectangles. All right, so as I have this going, they're following me around so I can see. Why would I want to do this? I wouldn't do this for gameplay. I would do this for testing, like for myself, to make sure while I'm testing collision with my player that he's actually colliding with the things I expect him to be colliding with. Okay. So there's our regular image data. Here is my array of rectangles for what the player is going to be colliding. So these are the 4 rectangles that get cut up. These 4 rectangles are not necessary. These are the ones so I can physically draw them on the screen. If you don't want to draw them on the screen, you don't need to do this at all. You just need these ones up here. This is a Boolean variable to determine whether I should show these rectangles or not. By default, it's turned off, and I'll turn it on whenever I want to. For now, it's set to the 1 key. So whenever I tap the 1 key, it turns on. These images are for the environment, so all the platforms, the pipes, the POW block, things like that. And here is all of my platforms' locations. So you'll notice I put them in an array. And the reason why I did this is so I could quickly loop through that array when I'm doing my collision detection. Now, you may want to break this up into multiple arrays, maybe one for the platforms, one for the pipes, things like that, and maybe have a couple separate things as well. So then in your method that checks collision with the platforms, you're not just checking collision with the original with this entire array. You might have to break it up and do multiple parts. but that's completely up to you. I like to keep it simple, so all my platforms that I can land on and collide with in the game, I like to keep it in a single array, just to keep my life easier. Here's our same forces and grounded stuff. Nothing changed here except my jump speed is boosted up to -7.5 from -3.5. Nothing different. Now, in our load content, loading the image, I'm temporarily storing the player width and height just so it's easier to read the code down here a little bit because I'm scaling the player. So down here, we're loading everything. Here, I'm setting the player width and height equal to 2.5 times its original size. If I wanted to modify that, I could. And then this is just me setting the rectangle, and you'll see where I've placed it vertically. Think about this logically. Go to the bottom of the screen, now subtract the height of the ground, now subtract the height of the player. That's where our player is located to start with. So he's starting on top of the ground. If I started him at the top of the screen, he would just fall down to the ground until he landed on it. This method here, set player recs, is what cuts up our rectangle. So I'm going to go to here so you can see this. So you can see for my head, my left, my right, and my feet, I did exactly what we did in the PowerPoint. I positioned it at 20% in. I said it's 60% the width of the image, and it's 25% the height of the image. So exactly what we saw in the PowerPoint. Down here, if I'm showing the collisions, I'm going to set those visible rectangles locations. Basically, I'm setting them to the same location as the regular rectangles. So that way I know they perfectly line up every single time. Okay, now I only do this if I'm showing collisions. Otherwise, it's a waste of effort. So don't do it otherwise. Okay, let's go back up to where we were. Where was it? So there we're setting up those player recs to start off the game. Here, this is just me loading in all of the environment stuff. So I'm loading in my 4 smaller platforms, my 1 larger platform, my pipe data, my left pipe, my right pipe, the POW block in the middle of the screen, and the ground itself. Now the ground, it's actually not as wide as my screen, so I just set it to screen width, so that way it stretches it across, so it looks okay. So that's loading everything in. Update is pretty much exactly the same. I have this extra little piece here to turn showing collisions on and off. Down here, we're doing the same thing as before. We accelerate to the right or the left if we're on the ground. And we add friction in, again, if we're on the ground and we are not holding any keys. So that nothing has changed there. We jump, exact same as before. We always apply gravity. This is what allows us to fall off that platform, even if we're not jumping. And then here, instead of just applying it to the X position, we also have to do it to the Y position now because we're doing gravity. And you'll notice that after I've moved the player, I set up my rectangles again. So I cut up that player one more time just before I do any of my collision detection. So there's the same wall collision that we did before, and there's our platform collision. So let's go to the wall collision first because there is one change in here. The one change that we have to realize is that, or 2 changes actually. First of all, I don't technically need to check the bottom of the screen anymore because there's a ground in the way. If there's ground in the way, then I can't collide with the bottom of the screen. However, I left this code in because you may want to kind of like, maybe create a gap in your ground or something like that where the player can fall through and land at the bottom of the screen and die, like a death zone. So I left it in here just in case I might choose to use it later on. And then down, you'll notice that I've also set all these variables as collision variable. It's just a local variable here. So if I get a collision, I know that I've readjusted my rectangles. So since I've readjusted my rectangles, I need to reset all of my collision rectangles, those 4 cut up ones. Right? And I only do that if I got a collision because otherwise it didn't move the original rectangle. And here's the platform collision code. Again, I have that same Boolean to decide whether I actually collided with anything. All right, now take a look at this. Loop through every single platform. If that current platform, platform I, collides with the player, the actual player rectangle, the bounding box, then we go to stage 2. Okay? So if the player collides with any one of the body parts, then we shift the player to just outside of that collision location. So if it collided with the feet, we're shifting the player up. If it collided with the left torso, we're shifting the player right. The right torso, we're shifting the player left. And with the head, we're shifting the player down. In every circumstance, you can see that I modified the speed value as well. So if I land on my feet, I want to stop falling. So I just set the speed to 0. Great. I also know that I'm now standing on the ground because I landed on top of a platform. And then here, for left and right, I set them to 0 just to stop the motion. Again, we could bounce it off by, instead of setting it to 0, multiplying it by -1. Similarly speaking, for the head, here I actually am bouncing off. So if I knock my head against the bottom of a platform, you'll see that it actually bounces off. It doesn't just fall, it actually bounces off. So it maintains its velocity, but just in the opposite direction. And then if I got a collision, I know I changed rectangle positions, so I gotta recut up my stuff every single time. Okay? I guess we could kind of modify this a little bit too. If you want, you could move this inside of the for loop, inside of here, so it does it every single time it finds a collision, and then set collision back to false. And the reason why you would do that is because you may potentially collide with more than one platform in a single update. Like if you were in the corner or something like that. That happens. So by moving it here, we should still end up with the exact same results. It's probably just a little bit more accurate, to be honest. So now we can move our player along, singing a cowboy song. Ole ole. There we go. Good. Looks like everything's still hunky-dory. Good. And we can walk off the edges still. Boom. 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 And that, my friends, is platform collision detection. Good luck and have fun.